All right, last topic, topic 5. I can convert circle equations between standard and general form. Alrighty, so we're going to take a circle that is currently in standard form. We're going to first identify the center and the radius. That should be pretty easy to do just by looking at the numbers in 16 and negative 11. That means the center is going to be negative 16, positive 11, and the radius would just be the square root of that number, which is square root of 4 is 2. Alright, for the next step, we're going to rewrite the equation in general form, which means we're going to have to expand those binomials and combine like terms. So I'm going to take my x minus 16 squared, my y minus 11 squared equals 4, and I'm going to start foiling things out. X plus 16 squared, that expands to x squared. I guess you'll have 2 copies of 16, so 32 x's in the middle, and then 16 squared is 256. Don't worry, I had to look that one up too. Y minus 11 squared, I'm going to have a y squared minus 22 y's plus 121. All that equals 4. So now I'm going to start combining like terms and putting them in the right order. General form starts with the number of x squareds. There's only 1. Y squared, there's only 1. The x terms come next. There's 32 of them. Then negative 22 y's. And then the constants, you have 256, 121, and 4 all left over. I'm probably just going to combine the 256 and 121 on the left side, and then just subtract 4 from both sides of the equation. That constant should be 373 then, and that would leave nothing on the right-hand side. So that is general form. If you take those coefficients and actually plug them into Desmos, that link in the document will actually take you to... Here's the, I can start replacing the A, B, C, and D values with the values I just came up with. And with any luck, the green circle and the red circle will map on top of each other. Something weird's going on with the gray. Let me zoom in. Okay. Yeah, and you can see that those 2 equations are indeed the exact same circle. The green and the red circles are right on top of each other. All right, so let's do it again. But backwards. This time we're going to take a general equation and flip it into standard form so we can see what the center and radius are. The technique for this is we're going to group all the x terms together, so x squared minus 20x, and then leave a big space because we're going to complete that square in a minute. We're going to group the y terms together. Y squared and 24y are going to go in parentheses, then again leave a space. We're going to complete the square there as well. And then I usually just kick the 243 to the other side and call it negative 243. So I haven't done anything new. All I've done is just rearrange the equations. Now I'm going to try and figure out what magic number will complete both of these squares. Half of negative 20 is 10, negative 10, squared is 100. So that is now a perfect square. If I add 100 to the left, I better add it to the right. Let's do the same thing with the y terms. Half of 24 is 12, squared is 144, so I'm going to add 144 to the left and to the right. The rest is just cleanup. All you got to do is rewrite these equations so that they're factored. Those x's, we specifically designed them to factor cleanly so that it factors cleanly into x minus 10 squared. The y terms are going to factor really cleanly into y plus 12 squared. And then you just have to figure out what all those constants are on the right-hand side. What's negative 243 plus 100 plus 144? Oh, it's this one. That's cute. So there you go. That's standard form. And from standard form, you can see pretty quickly that the center is just going to be at positive 10, negative 12, and the radius should be the square root of 1, which is just 1. Done. Let's do it again. With part B, we're going to group the x's together. X squared minus 32x and leave a space. Y squared plus 12y and leave a space. And I'm going to kick the 144 to the other side, call it negative 144. And then start thinking, what can I do to complete the square? Half of negative 32 is negative 16. When I square that, oh, we just did that a little bit ago. That's 256. Half of 12 is 6. Squared is 36. So I'm going to have to add 256 and 36 to both sides of the equation. We have designed the left set of parentheses to factor to x minus 16 squared. We've designed that second set of parentheses to factor cleanly to y plus 6 squared. And then whatever 144, negative 144, 256, and 36 are added together. 148 is the other side of the equation, which tells me that my center needs to be at 16, comma, -6, and the radius would just be whatever the square root of 148 is. All right, a third example. Group the x terms together, x squared minus 6x plus, leave a space, y squared plus 10y, and leave a space. Kick the -162 to the other side, call it positive 162, complete the square. Half of 6 is 3, squared is 9. Half of 10 is 5, squared is 25. Clean up the equations, factor and clean up things. X minus 3 squared should be the first set of parentheses. That second set of parentheses should end up being y plus 5 squared. And then the constant, my calculator is telling me, should be 196. Oh, I think that's a square, a perfect square of something too. Yeah, 14? 14. All right, so I think the center is going to be at positive 3, -5. And I believe my radius should be the square root of 196, or 14. Last problem in the review. Here we go. Let's group the x terms together. X squared plus 16x plus something. The y terms are going to group together. And I'm going to kick that constant of 10 to the other side, call it -10, and go to complete the square. Half of 16 is 8, squared is 64. Half of 2 is 1, squared is still 1. Factor everything. The first set of parentheses becomes x plus 8 squared. Second set of parentheses becomes y plus 1 squared. And then those constants on the right-hand side, those all add up to 55. So there's my standard form. My center is very clearly -8, -1, and my radius is the square root of 55. Holla!